Alright, draft science video response to Hythloday, kind of a rude video again, and I'll point that out in the video. I will hope to get to a two-slit stuff at the end, just an observation. I haven't really worked it out myself yet, but it's sort of maybe the maybe the beginnings of an explanation of the difference between the single slit and the two-slit. Anyway, so we'll get to that later. So let's play this.
So you have to realize with the Sage inverse square law, as discussed.
Who has to realize? Again, so I'm going to just keep rudeness fouls. Now, maybe you don't understand that, but that's sort of a rudeness foul. When you presume that somebody doesn't understand something, that's a rudeness foul. You could suggest that I've noticed something that may be problematic to your theory. Now, that wouldn't be rude, some kind of statement like that. But this "you have to realize" thing is called arrogant and obnoxious. So, yeah, we'll give you a little rudeness foul for that. Keep track.
That when you consider the shaded area protected by a large shape.
This doesn't even really get to the point. The point is that you could also argue, as we've already pointed out, the density issue. So, putting up a block as if it blocks 100% of this force, even in Lesage's time, the argument was made that there is a ton of this stuff and that the matter has empty space in it, and that most of the gravity goes right through the object. So it's only a tiny percentage of the actual force that is blocked. So, you're not even being honest to the conversation that has been previous, which makes your foul even more egregious, as if somebody needs to realize something other than you.
We have the inverse square law as discussed. But what you have to realize...
So you've said it again, so that's 2, another foul.
Is that at some point, when you move from the macro scale objects to micro scale objects, to the absolute smallest objects, shading isn't really what happens as an inverse square law.
Right. Now, nowhere have I argued that the inverse square law applies to nuclear arrangements, the orbits of electrons, the arrangement between protons and neutrons. Never have I suggested those are inverse square law arrangements. I think we already know that atoms have orbitals that are set by some other mechanism besides inverse square, just by the fact that they have these energy levels and that they don't do the in-between thing. So I think that's already established. So again, it's not something I need to understand. Of course, the inverse square wouldn't be something, it's like most any force you could possibly invent would have to break down at some point. Einstein's gravity doesn't hold. It breaks down. But regardless, the point is it does. I already am aware of this, so your assumption that I'm not aware is presumptuous and arrogant and rude.
A particle with a trajectory encountering another particle in regards to some other particle or other particles either obstructs or doesn't obstruct the path to any particular particle. It's just a simple yes-no acceleration of it's either in the way or not in the way. Statistically speaking, this.
Yes, but what angle of what the byproduct of this interaction will be something variable with each interaction. So, I mean, I could be obnoxious and say what you need to understand is that this is one moment of time, where this is measured over a much longer period of time. So when we say there's an inverse square law for gravity, what we're saying is averaged over time, the amount of gravity fits this rule. But at any one moment, the gravity on me could be 13 feet per second, it could be 100 feet per second, it could be 1 foot per second. At any one Planck constant of time, gravity could be quite variable. And it's only because of our perception is 1 billion times too slow that we can't see the fact that the gravity is actually quite variable, and that it averages to the inverse square law. So what the argument would be here is that the average of these impacts is a certain parabola, okay, of likelihoods of what the impact will result in, what the two interacting bodies will produce as a net effect over time. So this single event has to be extrapolated over millions of events that take place to, say, maintain the order of an atom. We're talking about millions of events, and over those millions of events, some order, some rule of pressure will be created. Now what that rule is for the atomic structure is going to be slightly different, or different than what it is for on larger scales that involve more bodies moving in more directions. So obviously the directionality becomes another issue of net probability. What is again, the electron is, let's say, doing, so not even the right way to say it, each one of the mechanisms inside of the atom has already a filtered dynamic in terms of its capacity to be moved by gravity based on its current movement. And so the acceleration can only be given to something capable of being accelerated. Something that's not already moving as fast as the gravity would be the point. And that fact, and the fact that depending on the condition of the matter overall, is what brings the inverse square rule to being the probabilistic outcome, not the instantaneous. This is an instantaneous event. This is one event in one moment of time, and it can't be compared to billions of events over a longer period of time, I guess is the main point. So you can see that you need to better understand.
Inverse square law will break down at the microscale. So you can see under the Lesage system.
Okay, so another problem. So let's call it something else. The Lesage system doesn't cover any of this nuclear particulate force. It wasn't a particulate force that was intended to unify all the forces. It was just a description of gravity. Okay, so it did all it needed to do for gravity, and that was its purpose. I still think I can argue just by applying it to some sort of macro but not nuclear, I could still make that particle theory work. But I think it works even better to quantize it. So Lesage wasn't a quantizing theory unifying all force law. So there's really no point in saying Lesage doesn't do this. And in the context of the fact that Einstein has given you a theory of function that basically just says the empty space did it and gives you absolutely no mechanism, this looks a little petty. So anyway, I don't want to slight, look, Lesage I didn't build this on Lesage's theory, okay? Somebody else directed me to Lesage because they said my particle theory sounded like Lesage. So I don't mind giving Lesage credit. I think he was screwed by history. I think the fact that he might have stole it from some other guy who was screwed even more by history, I would like them to get unscrewed, okay? But maybe that's not the job in these videos. These videos are about my unification particle theory. So we'll just call it a particle force unification theory. All right, instead of Lesage, particle force unification theory. You can use the acronym PFUT.
That macro objects will have a tendency to feel a force between them, but at some point, on a molecular level, this will break down.
Well, it says again, it's not a force between them, okay? It's an exchange of directional information, so I'll try to go through this with you again. The idea is that there's an exchange. So something, let's say something needed to orbit something else, and so this is the idea was it would be in this orbit. So at any one point, its vector would be this way, let's say. Something has to knock it down. So what happens is something interacts with it in this, say, something comes, well, here, put it up here, comes at it in this direction. And what is exchanged is this. Now this leaves in this direction, and this leaves in that direction. And so the process of just exchanging directional information is achieved. So all the things come in this way, and they leave that way, essentially, or some way like that. Let's say that way. And what is happening is this keeps gaining all this down direction. So it keeps gaining this directionality here. So that's all that's taking place, is that whether you even say the quanta switch places, it just doesn't matter. You could say that this quanta exchanges its position with this one. So it just knocks this one out of the orbit, and this now has this directionality. And that's what's really happening. And I would argue that these orbits are probably quite eccentric. I mean, there's probably doing a lot of this kind of thing in the orbit, okay? It's probably not what you would call a beautiful circle in these nuclear products. It's probably quite an ugly orbit that has quite a bit of eccentricity in it. So that's how it works on the macro level. There is no argument that inverse square is happening here, because inverse square can't happen here, because these are individual interactions. But the net product of these individual interactions, when you take them en masse, is that a big pile of directional information, most of it internal to this one object, right? There's no external impact to this process until you have some force, some extra amount of gravity coming from some direction, and then this starts moving in a direction. And it isn't until this wobbles in a direction, okay, that it becomes relevant to this inverse square rule. So the inverse square rule has to do with the amount of pressure coming from some direction, okay, but it's not going to be relevant to the nuclear bits. So again, you have to understand the scale difference. There's a universe of magnitude between them. So the quanta are on 1 million scale, and then the atoms are on, 10 billion scale, and then the molecules are on 100 billion scale, and then you have us on trillion scale. So you have to understand there's a huge depth of density difference at each one of these scales. And so you're not going to, you know, it's the same functionality, but you're not going to see it express the same exact rules on each one of those different levels. Of density.
And I think you could intuit.
And recognize it's not only just density, it is time. Our scale has a huge amount of distance at the speed of light in each second. 168,000 miles of distance in each second. That's not happening here. Here they're doing it their second. This thing's second. Okay? There's 168,000 of these events in every one of our seconds. That's what has to be understood.
But that the fact of this might allow for the creation of objects such that the particles then might have some average speed, wherein particle collisions, the gravitation, if you like, has reached a kind of limit, and what we have is something behaving like a particulate body.
Well, I mean, this is what I already did this in my last video, so I really don't understand. Yes, the pieces are all moving the speed of light in here, and the eccentricity of their orbits can have them moving. They don't need to keep getting hit if their orbits are eccentric. So if they're orbiting around each other, they can have movement in a direction just based on the imbalance of those rotations. One moves in, one rolls over it, another one moves in, the other one rolls over it. They will eat space without overt interaction. They won't need something overt from gravity to do it if they already have an imbalance in their orbit.
And it could have an average speed, wherein this at some level, at some density on the outskirts.
Now again, there wouldn't be any outskirts. The whole argument is this gravity is so minute and so dense that it's affecting every single particle. Every single quanta is in a sea of it. And it can't be isolated from the substance of it. It can only be isolated from a percentage of it. So the density of it is still massive, and all it's getting is blocked is a percentage of it. I don't know if that's the best way to say it, but it's the best I can do for now.
The gravity effect has faded out, and you might get particles joining this system, and statistically you'd have as many leaving the system.
Right, well the whole point of the gravity thing is that it doesn't do this join thing. So it just exchanges directional information. It goes in this way, it goes out that way, it imparts directional information on some piece in here. It changes the direction of one of these pieces. One of the pieces in here going this way is converted to going that way, and the gravity goes out in some other way. But that's what's being exchanged. This directional information is being transferred, and new directional information goes out that imparts this information, this vector. Some percentage of this vector is imparted onto this body. So it loses directionality going down and gains directionality going that way.
And if the an average velocity in a particular direction as an aggregate, you would envisage that this outward gravitational interactions would be curtailing the straightforward path and maintaining some sort of aggregate globule of the native particle, so to speak.
Right, so this is just a reiteration of the point made in the previous video. Like the school of fish, if it has a pattern and you move it, it starts moving in a direction, the pattern will have to slow down a little bit to accomplish the movement, because now the particles have to spend 1/100th of their time, or 1/1000th of their time, or some percentage of their time going that way. They have to take that extra step every 100 cycles.
I can't speak for the maths of such things, but I could intuit, given that it's understood that we have the 1 over the inverse square rule in application for large objects and such.
So exactly, for large objects of high probability density. So the inverse square rule applies to gravity, magnetism, and electricity. It doesn't necessarily apply when you get smaller than that.
It's clear failing of the inverse square law at
again, so I'm going to call that a rudeness to say that it, well, I'm just going to say you've been refuted. So that's a refutation. I've refuted this argument by pointing out this is one instant of time. This is a much longer period of time. There is no inverse square in this minute amount. If you do it at this one moment of time, you won't have an inverse square rule. That it is gravity is in fact variable, and it is only because of our lack of ability to see that variability that we don't recognize it. But it is variable. But there is the net outcome, probabilistic outcome, will end up being the inverse square.
Minuscule levels, it's obvious that we have mass contained within some boundary, and thus that boundary of mass can have average velocity.
Well, again, this idea of mass is the tricky one, right? Because the point is that it's really arrangement. Arrangement creates what we call matter, and then we give it mass. But mass is really just a collection of directional information. So it's something gains mass when it is multi-directional. If it's moving in one direction, if I take matter and I move it at the speed of light in one direction, it isn't matter anymore, it's back to being energy.
And it won't be light speed velocity, or it may not be light speed velocity, and any speed less than light speed velocity, if all particles are in fact travelling at the same speed, means that in order to have an average slow velocity, it's contained with and pressed back by impacts into a springy type orbit, if you like. I think that would be consistent.
I'm not exactly sure what he said there, but I'm sure it's exactly what I was pointing out, is the fact of the electron speed would end up being, the idea of it going 1/5 the speed of light is very consistent with the idea of, as a maximum speed inside orbits, would be very consistent with the idea that it can't maintain the orbit if it goes any faster than that. It's likely to stretch it too thin, and whatever gravitation is holding it together would be lost.
Problem inmendham has.
There's another rude statement. You know, you could suggest that you have a theory, a counter theory, that you don't think this is correct, and this is a reason why you don't think it's correct. But to say I have a problem, I don't have a problem. I have an answer to any kind of nitpicky piece of shit you want to bring up. To assume I don't have an answer when you haven't even asked your stupid, idiotic question is just fucking rude. 3 rudenesses.
Or anybody for this particular style of theory is why are there other particles? I think this is a reasonable argument for one type of particle,
again, if you're going to call this is now, you know, we talked about whether we should call this gravitons or photons or this or that. If you're going to call an electron a particle, then the game's over if you're not understanding that the electron is not a particle. It is a collection of quanta trapped in orbits. It is not a particle as in the quanta sense of particle.
But why would that electron orbit around a nucleus? And the nucleus is 2,000 times larger than an electron.
Well, guess what? The sun is a lot bigger than the Earth. You know.
Or even a neutron or a proton is 2,000 times. The nucleus itself is orders of magnitude greater.
Yeah, well, I don't know. Again, so why is this a problem? I've explained it previously that I believe what's happening in the nucleus of the atom, in the arrangement of the atom, and what is creating these set orbitals, is that this now, the quanta are being polarized as they are gravitationally going through these bodies. So now it's polarized gravitons, and the polarized gravitons have this effect of being transparent in that they don't affect an object at a certain orientation, or they affect it twice as much. So if the substrate, the orbit, is in such an arrangement, maybe this way versus this way, the one polarization will go straight through, and if it's the other way, then the polarization is blocked entirely. So everything thrown at it, if it's polarized gravity, would go right through it versus not being blocked 100%. So this is the function of magnetism, and that this internal forces here are not only gravity that is now pushing on this item. So gravity is pushing to this, every gravitational center, just like Einstein's theory of cosmetic function. Every gravitational center creates one of those dimples in space. And the same is true here. There's convergence wherever there is a graviton. And so the point is that when the gravitons are still each, so inside of the electron, each one is being affected by this, you know, this pressure, and then this whole thing now is also being affected by the pressure. So the pressure, and then the atom is affected by the pressure. So it scales to each level. So you have to kind of understand that the scale still remains. So inside the nucleus of an atom, what I would answer to you is that there's not only gravity creating the inverse square kind of effect, gravity. It doesn't have to be inverse square, but whatever. There's not only a gravitational relationship between this body and this body, but that these bodies are now polarized, which means that the gravity goes through here, and the stuff that isn't pushing the electron down comes out polarized in one direction. So now it's positively polarized. And say if this was the neutron could be invisible to positive polarization, so it goes right straight through the neutron. And so there's no pushing away effect for those two, but for the proton it's exactly the opposite. There's a push, so there would end up being a pull between the neutron and the electron, and a push away between the proton and the electron, and those two are orbiting each other. So you can see how this dance would end up creating a on-off kind of effect, where the orbiting thing, the electron, would be pulled in dramatically, released, pulled in, released, pulled in, released, pulled in, released, and that's what's maintaining its continuity. But I mean, this is a level of minutia that I really don't think I'm obligated to explain, especially when you look at the Standard Model and how they don't explain quarks. They don't explain how any of these things actually act. So I mean, this, I don't mind, but I'm just saying, to say that this is some sort of catastrophic issue, I think it's just so bogus.
In itself, as an aggregate of these particles. Inmendham has criticised me as nitpicking for asking about the geometry, but as discussed previously about...
Yeah, no, it is just nitpicking. What has already been argued is that there's generally a force transfer, a directionality transfer, and you really don't need the specifics. But I can just say that the quanta are indestructible. So any point you hit on one has no elasticity. So no matter what shape they are, as soon as there is an impact on any speck of them, there's an instantaneous reflexive reaction. And it's always just carrying those vectors. Those vectors remain consistent. So there's one will leave going this way and one will leave going that way, as if they never interacted, but in a sense they did. Wrong way to put it. They will exchange directional information, directional identity.
The nature of vector interactions, and as Inmendham likes to call it, directional exchange, when they're the same lengths on these vectors. The thing which is understood as producing this geometry is that they be circular.
No, I've never said that. I said light has a shape. It could be like a Pez candy. Alright, it has a certain thickness, let's say. I'm not sure of that. I mean, that might be one of the reasons why light doesn't interact in the direct horizontal crash. So the exact horizontal crash, maybe that never happens. And that it can only happen on, some sort of lesser angle. The 90-degree crash never happens because the quanta has no thickness. That could be a fact. I don't know if it is or is not. It doesn't really matter. The point is, we know one thing, I think. We know quite certainly one thing, and that is light has polarization. So we can understand that if I'm saying light is quanta, that quanta is polarized. So it either is this or some variation in an angle. So I would say just make it dominoes, okay? Make it a domino, and it goes this way, or it can go this way, or it can go that way, it can go, all these levels, but I mean, that's it. It flies like a domino, face on, not flat side, edge on, and that's how it flies. So it's a domino flying that way. And no matter what it hits, and it's made out of the hardest substance in the universe, so no matter how it hits something else, there's an instantaneous reaction that is purely kinetic. So doesn't matter what piece of it hits. It doesn't matter whether it hits the corner or the side or this or that. It just doesn't matter. It will always react consistent with these. One thing will go as if they go right through each other.
Very cool. See, if it was hexagonal.
The point being, this item gets this direction, this item gets that direction. That's the point. That's how you create an orbit. You keep hitting something and bending its direction.
You wouldn't expect or pointy shaped or barbed shaped. You couldn't expect such a regular interaction.
Well, yes, you could if you understood there's no friction, and if you just say they're not elastic. They're not made out of rubber. So I can do the kinetic ball thing out of squares. I could do the kinetic ball thing out of any shape. If you take away air resistance, it'll work just fine.
Particles. So it is a fundamental question.
Well, you take away air resistance and make them out of a substance that can't slide or you know, where they have to bang off of each other. So obviously you can't, if you make them angular and then have the angles not meet, so there's no impact point, well, yeah, then you have a problem. But the point is there is no sliding or any of that kind of stuff. It has to bounce off of the very surface it hits. It cannot slide along the surface. It must reflect exactly where it hits. So I could just make this a spiky ball. I can make it anything. It just doesn't matter if I make it out of something impervious or inelastic.
So I go back and say, why is it we have an aggregate mass of these tiny inmendhams that form an electron?
Well, I want to just put that down as another rudeness.
Why does this aggregate mass then orbit a nucleus?
Well, I mean, quite obviously, it's doing the blocking of the force. There's the constant pressure. I don't know, why is this a problem for you? If there's a density of these things collected here, and that density presumably is thicker than the density of this field, so that would be the implications of being trapped in orbits, is that you end up with a higher density than in the field. Then there's automatically going to be a tendency to create the shadowing effect. So there's gravity. But my point is that I've already said it in other videos. I believe it's the magnetic and electrical forces that are tying atoms together. So it's the polarization.
I would criticize immensely.
Polarization being it's the same amount of gravity. It's just that it's polarized, and by being polarized can have a greater impact or a lesser impact depending on the structure of the plasma of quanta.
And that in these hand-waving explanations from...
Okay, there's another one. Hand-waving explanations? What the fuck is that, jackass? I'm not waving my hands. I do find you incredibly obnoxious and frustrating sometimes, but what the fuck is that, shithead?
He too often starts to describe the function of fields.
I hadn't watched this part yet, so this is amazing. Yeah, so go ahead, let's see this.
When in fact, it is the function of fields that we're...
When in fact, so this is like some sort of counter argument he's going to make.
Trying to describe other fields.
He hasn't described what I contend. He's just going to tell me I'm wrong. Why? You should at least explain what I'm saying before you say you're countering it with something.
Not just the magnetic field as discussed, but the actual... He appeals to the field-like nature.
There is no field-like nature. So again, the argument being made is that this field is not a field. And number one, it wouldn't be this exaggerated. It's actually gravitons leaving in straight lines. Alright? That's what the field is made out of. And when you combine the effect of these two fields, you end up with a point. And that's what the field line is, where the net, if something had no velocity, and you put a spot here with no velocity, it would fly perpendicular to this field line. That's all this field line represents, is that there's a balance of the forces. So the gravitons flying this way from the South Pole and the ones coming from the North Pole add up to a combined direction that is perpendicular to this little point. So field lines essentially are really hexagonal. I mean, they're what's the word for that? You know, diamond, faceted. They're really just facets, and they're facets that determine where something would move if it didn't come in with any directional information. What direction would it leave this point from? And that's what a field line represents. So field lines, obviously this way would be all this north side, so that it would leave this direction. So it's always leaving in a perpendicular to the field line, and that's representing the balance of the gravitons. So you have to do a lot of, but that it's just arbitrary in a sense that you can have many field lines. You can have many points where you could balance the two gravitons leaving, you know, the probability, the probabilistic impacts, and where the direction would come off. So let's see how he butchers this. There are no forces. All force is gravitons. All force is what you could call photons. It's all some quanta moving the speed of light. Everything moves because quanta moving the speed of light are either forcing it to by giving it acceleration, changing its internal structure, making it move because its structure was changed, giving it an eccentric orbit that will wobble, giving it a wobble, or, well, that's it really. So it's all a push system in the end, and these are all a whole complex series of filters.
Rather than explaining the field-like nature and explaining the orb.
I don't even know what a field-like nature is. I don't even know what you're talking about. I've never made a video about any field-like nature.
But in terms of what I'll call the inmendhams rather than protons, electrons.
Yeah, fuck you. Number 5. I've called them quarks, and I've called them, well, quanta. I did use quarks in the last explanation for what probably make up these things. There's a collection of quarks, which would be the smallest orbitals. But whatever, asshole.
We call these the inmendhams. I think that's a good name. Because you could postulate that the inmendhams,
the quanta,
all act together and form a globular mass and interact with nothing else, and there could be...
I don't even know what interacts with nothing else. That would be impossible. They can't be a globular mass unless gravity's constantly pushing them together. Without gravity, all matter falls apart.
Gravitons, which create another type of mass with different coefficients and different rules.
So does this make sense to you anywhere? I don't know what this inmendham thing is if it's not gravitons. There's just gravitons. When they have a frequency, they're called photons. But there's just gravitons. There's no inmendhams.
And cause blobs of that. Now, this might sound ridiculous, it might well be, but given that we've just discovered that, you know, 90% of the universe is unaccounted for.
Yeah, well, none of that means much if you don't explain how they discovered 90% of the universe is unaccounted for. They discovered it because they keep using lensing as a way of deciding how massive bodies are. And my argument is Einstein was wrong about that one too. You can't use lensing to dictate, to understand how gravitational something is. There's no real correlation between the two that's exact. Lensing is a symptom of gravity created by how many particles are in the gravity. Gravitational fields will have particles in them. Particles change the direction of light. Light is deflected by particles, not gravitational pressure. But anyway, well, particles meaning electrons. Absorption and reflection by electrons, to be specific.
Are seemingly unaccounted for.
Exactly.
It's not that preposterous. But this is the problem with not having the maths, and this is the problem in...
No, I don't think there's any problem. So again, this is the problem without having the maths. Again, what math? Oh, that's right. The inverse square rule works on all these big objects. I will eventually, okay, be able to model more specifically the exact density of the gravity. But I mean, again, you have to do some work to be able to figure out what that density would be. Einstein just pulled it out of his ass, times the speed of light squared. Do you think that's actually the number of quanta there are, the speed of light squared? Do you just think it comes out that way, that you just times the speed of light squared? You think that's really the truth? Or do you think that's just a made-up constant?
Making a comparison with the standard model is that it has a reason with only 12 or 15 sort of elementary particles for predicting a whole zoo of particles.
Well, again, I'm not gonna. It's not my obligation to explain the nuances of the standard model. I think the standard model is pretty much a pile of shit. So it's kind of irrelevant to me. I don't think they have any photos of any of these things, so I don't really think I have to take too much of that seriously. I mean, as I've pointed out, particle accelerators aren't really particle accelerators. They're energy creators. They convert matter into energy, and then they smash the energy into each other. They're not crashing matter into matter. They're crashing energy into energy.
So that was just a little bit of add-on thought I had about the inmendham Lesage theory.
So anyway, yeah, pretty bad actually. So 6. I got you down for 6 rudeness. 6 rudenesses. Okay, so yeah, you have to realize 6 rudenesses. Anyway, so I'll get to the 2-slit thing. I think I still have time, right? Oh, gee, running out. Well, 5 minutes might be enough. All right, so this is what I've realized. So by my so let's just superimpose them on each other. So let's say you have a single slit, all right, and then you have the double slit with a tiny impediment. All right, so that's the idea. So what? Oh, yeah, well, that's not a good drawing because I've made the single slit much bigger. So let's just have a single slit here of the same size as this slit. So the single slit would be the same size as these slits. So what you could sort of see off the face of it, obviously, is the amount of light that would go through these two things. There would be twice as much light that would get through this one as that would get through this one. So that's the first thing you can notice, right? 2x the number of photons. So, and what's the and my theory is that there's these densities, these what you could consider sort of a magnetic field, but I'm just going to call it static electric field. It doesn't matter, but that in these little, on any surface, there's a radiation from that surface of. Gee, it's too bad that doesn't focus very well. Maybe take the lens off. That's not too much better, is it? No. Anyway, so you have these little, like a magnet, but they're density fields, let's just say, of ions that are between any surfaces. So when you move from one surface to one medium to another medium to another medium, there's always ions in those transition points. So the transition between water and air, there would be a bunch of ions, and that's what's diffracting light. So anyway, so here you can see that as the light would go through, the densest of the field, the strongest field would be here at the edge, and the weakest field would be here in the middle, right? And you'd have most of the light here in the middle because there's no impediment. So in the 2-slit, what do you have? Well, you have the same fields here, but you have fields on both sides like that. And so first you have an impediment that's blocking some of the center focus lights. So the most intense light is being blocked, some of it. Some percentage of the most intense light is being blocked by that. Why doesn't that focus better? That is really irritating. So that center impediment is blocking the most intense light. And then the second truth here is is that the intense, so this is your light intensity. Remember, it's most intense, you have a parabola of intensity. The highest intensity light here in the middle, the lowest intensity on the sides usually. And what's happening is the most intense light now, where the most intense light before was going through the middle, which is the weakest field lines, right? So the most intense light goes through the weakest field lines. With the two-slit experiment, the most intense light is going through a strong field line on both sides of that impediment. So the strongest light is now going through the strong fields, right? So it's the same number of fields, the same number of probability of hitting a field line, the same amount of probability of hitting one at different locations. But the big difference is between the single slit and the double slit is the fact that now the light, the most intense light, is going through a strong field rather than a weak field. And that's why there's a much stronger diffraction. So that's why the bar pattern, so understand that the difference between the single slit and the double slit is that in the single slit the bar pattern looks something like this. This is 8 or 9 times weaker than the center, and in the double slit experiment the pattern looks more like this, where there's the high maximum, and the nothing, and these are not as, these are like half or as strong as the peak one. So instead of an 8x, it's a 4x or something like that difference between the peak and the second maxima. And so that would figure out quite nicely, fit quite nicely to this theory that the difference is that now the most intense light is going through a strong field of the center impediment instead of going through the weakest field in the single slit. Yeah, so I made it. I think this is important. Yeah, I think it's really good. Anyway, so I think it nails it almost. So this is something else that needs more work, but clearly that's the difference. The difference is there's twice as much light in a two-slit, and the most intense light is now going through a strong field rather than a weak field. And I mean by field the density of ions. A strong density of ions versus a weak density of ions. A strong density of ions versus a weak density of ions. Very important. Surfaces are very important. Yeah, surfaces have influence. Okay, so that's enough. Till next time and such. Rolling right along, I think. But yeah, I'm going to try to find somebody less rude to converse with. Yeah, so Hythloday, I'll be dumping you as soon as I find somebody who can show a little bit of respect. Yes, I will be dumping you. Yeah, because you just you just can't do it. You just seem that you can't make a reasoned argument. You can just make insulting ones.